Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will discuss about SG iron part 2. Now we have discussed that the matrix of the grey cast iron and SG iron is same. Only the solidification mode changes the formation of the carbon from flakes to spheroid. Now spheroidal graphite enhances the properties of the SG iron. Now there are some other elements also which is there in the matrix, and therefore, as we know, the carbon content is 3 to 4%. Higher carbon has had greater number of spheroids. Therefore, increasing carbon content improves solidity, increases cast ability. Now, carbon content is correlated with a term which we call carbon equivalent. Now, if carbon equivalent is 4.3%, then it promotes development and growth of graphite spheroids. Now, carbon is less dense than spheroids floats towards the cope. While casting, we are having cope and drag. Therefore, this spheroids will float towards the cope, and the spheroid in the cope then will be denser than in the drag. Now, therefore, this flotation can be prevented if this carbon equivalent is increased to more than 4.6%, and the section size of the casting is more than 25 mm. Now, carbon equivalent can be given by this particular equation. Now, C is the carbon plus S is for sulfur and P for phosphorus. S the percentage of sulfur plus percentage of phosphorus divided by 3. That the total percentage gives the carbon equivalent. Now, if this carbon equivalent is more than 4.3%, we call it hypereutectic. If it is less than 4.3, then we call it hypoeutectic. Now, hypoeutectic leads to carbide or graphite solidification, while while hypoeutectic promotes formation of white iron. Now, another calculation for carbon equivalent for different material, for different elements present, can be given by this particular equation: manganese, silicon, nickel, copper, chromium, molybdenum, vanadium, etc., etc. Now, therefore, if different alloying elements are present, we can calculate the carbon equivalent. Now, still with carbon equivalent greater than 0.4%, weight percent cannot be welded. Now, therefore, silicon is also an alloying element. Now, in SG iron, normally silicon is 1.8% to 2.8%. Now, significant effect, as we have seen while calculating carbon equivalent, that the value affects the number of spheroids. The carbon equivalent get enhanced, and then therefore formation of spheroids, as we know, if carbon equivalent is more than 4.6%, it enhances the number of spheroids, and the occurrence of the occurrence of rotation will take place. Now, silicon increases the spheroid formation during electrolyte transformation, hence strengthen. Now, spheroid formation strengthens the iron. Now, late addition or inoculation of silicon influences more in the control of spheroidal graphite. Now, another is sulphur. Now, sulphur content after treatment is about 0.015%. It increases the amount because we have to desulfurize, and therefore by using magnesium, and therefore the requirement of magnesium increases with the increase of sulphur, and it is due to the melting process, and therefore we have to control it over there. Another is phosphorus. Phosphorus is a maximum of 0.05%. It forms brittle structure called steadite in SG iron and grey cast iron. Now, therefore, it deteriorates the quality of the product, thus adversely affecting ductility and toughness. Other elements which also present as an allying element are as manganese, nickel, molybdenum, copper may be designed, now depending on, may be designed to have high strength or greater toughness, increase high temperature properties, corrosion resistant properties, and depending upon this, we can incorporate, induce different allying elements. However, there are certain elements which affect adversely and therefore to be avoided. Elements that given trace of it gives deleterious effect, like some of them develop flake graphite like lead, titanium, aluminium, antimony, zirconium. Other promote formation of perlite or iron carbide, again deteriorating the quality of SG iron, like elements like arsenic, boron, chromium, tin, vanadium. Therefore, they are to be taken away, eliminated before development of spheroidal graphite. Now, therefore, what is the melting practice? Now, generally cupola is used for melting common SG iron and grey cast iron. Now, cupola is being used by 75% producers. They employ acid cupola, while the producers using basic cupola has also been provided with separate melting facilities. However, induction furnaces are also used in many foundries. Acid melting is 4 to 5 times less costly than basic one. Acid cupolas are not capable of reducing sulfur content. Therefore, it is a demerit. However, an applicable amount of high-cost magnesium alloy to be consumed and necessary to be desulfurized iron. Now, basic cupola characteristics to control sulfur. Therefore, average sulfur content before spheroidizing is 0.0025% to 0.03%, but the higher operating cost, higher silicon losses, greater carbon pickup during melting. Induction furnace is also being used, that may be of low frequency, up to 60 cycles per type, operated for cold melting or duplexing, used to superheat the melt. Generally being used to superheat the melt. Extremely close control of composition is possible when we are using induction furnace melting. Now, magnesium treatment. As we know, magnesium that promotes to develop the spheroidal graphite. Not only this, it also promotes to grow the spheroids. Furthermore, it prevents the formation of flake graphite. Now, therefore, magnesium treatment is very important, and it is responsible for develop the spheroidal graphite. SGRN also requires inoculation Inoculation or post-inoculation refers to make an addition to the melt to increase the number of graphite formed during solidification. Now, increased number of graphite side increases the graphitizing tendency and reduces stealing tendency. Reactive carbide results greater hardness. Inoculation ensures their elimination. The most effective inoculation for SG iron is ferrosilicon alloy. Now, silicon addition to iron as post-inoculation are also effective. Now, 0.5% to 1.5% silicon is added for inoculation. Now, these additions are made by reladling the treated iron into ferrosilicon placed in the bottom of the ladle or to the metal stream. Now, the foundry process to control the moisture content must be carefully controlled because this SG iron melt oxidizes easily, and therefore we have to control moisture content. Preferred pouring temperature is 1430 degrees centigrade, even more. Now, therefore, the gating system, it should fulfill the following objective. It should retain the slag and dirt in the gating system itself, and introduce metal into the mold with little turbulence, control the rate of entry of the metal into the mold cavity, establish best possible metal distribution in the mold cavity. Now, therefore, a sufficient number of ingot minimizes the amount of metal flow into each gate. Now, therefore, gating ratio of 4:8:3 type is generally suggested. It is desirable to provide runner at a height twice the width. The height is twice the width of the runner which is being provided. Now, heat treatment of SGRN is possible, and it has excellent response to heat treatment. Its heat treatment are done for stress relief, annealing, normalizing and tempering, off tempering and mar tempering, and this is all about the usage of and foundry of SG iron. Thank you very much.